Hello, hello everyone. We move forward with the C programming, the session 9. This session is about the pointers and dynamic memory allocation and then function pointers basically. Here we can see over that basically what is pointer. For example, we have our finger. For example, we are pointing to some location, something like some bird is there. Our finger is a pointer and its content is the bird basically. Here with respect to C programming, the pointer is that one which points to the memory location, similar to a bird, our finger pointing to the bird. Here is this is the pointer pointing to the memory location that contains something. It can be an integer, it can be a float, it can be anything. Similar way, our finger can point to a building, point to a flower, point to a bird or animal. We have that similar kind of thing. A pointer can point to a memory address. That content can be anything, integer, any data types, integer, float or anything. That is the pointer. It's declared as it can be declared as a normal variable, and it will be used during the dynamic memory allocation scenarios. And the syntax for defining a pointer is data type and then star, then variable name basically. And here we have that integer star pointer, for example. And a pointer can also be extended to the multi-stage by adding stars. For example, we can, similar to that, our array can have single dimensional or multi-dimensional. Similar way we can do that. The pointer can also be single one or multi-dimensional. That can be done over here basically. Here we can see how we can able to access the pointer of an C programming, how it points to the memory location. That we can able to see here. Maybe we can take a small example and we shall move forward. Maybe we shall start with that thing. We can start pointer.c and include stdio.h and then integer main, integer argc character star argv over here, and then we can able to do over here. And I'm going to define integer a, and I'm going to define integer star ptr, an integer pointer basically. Here I'm going to do printf, enter the integer colon scanf %d comma $a ampersand a. Now I'm going to do something like this basically, that any local variable cannot be accessed, should not be accessed before initialization. I'm going to initialize this. For example, ampersand will give that memory location and pointer can take that memory location basically. Here I am going to do pointer and I am assigning that ptr to point to that memory location of variable a here. And we can see with that print, for example printf, how we can able to access the value of a is %d and pointer content %d then /n. I am printing a, and then to access that content of the PTR we should use star ptr, then it will give the content. Basically here maybe we can compile gcc-o ptr.c. Yeah, it got compiled. I'm going to give the integer some 3 4 5 6 and I'm getting that. Basically here ptr.c, here we are assigning, we are receiving that the integer from the scanf using the scanf, and we are getting that we are making that ptr to point that memory location of a, so that the a contains 3 4 5 6 after the scanf. Since that ptr points to that location, for example of a, then that its memory location, when we are trying to print that content of that memory, we are getting that 3 4 5 6 over here. This is something like a small introduction about the pointers, how we can be able to use that here. And for example, we can use similar way, instead of integer we can use any data type, float, long, character, anything, but it should be something like the whichever be the pointer location and the memory location, that should get matched. For example, if you are using float a and a float pointer, then both should be a float in a and a float b. Basically, for example, we are making that pointer as a float pointer. For example, we are making our finger to show only that birds, then that our finger should be bird pointer. Similar way, the pointer should point to that location of float, then it should be a float pointer. If it is pointing to that integer, then it is an integer pointer. Something similar to that we should match with that data type accordingly to access that content of that memory location properly. Yeah, now we have that. We can do some more thing. For example, I'm going to do this one e. I'm going to do that string dot c. Sorry, I'm going to do that array dot c. That I'm getting that mocks, all those things, and we can do that here. And I'm getting that mocks of everything, and once I can able to print earlier. Now I am going to print in a different way using the pointer. Here I'm going to get it here, integer star ptr, and then here we will see over this for the similar way for integer I equal to 0, I less than 10, and then I plus plus. I am getting that, going to print it in the different formats, something like printf. Usually we used to print that content mocks of I. I'm going to print that how it is behaving when it was normal to the pointer, and how it is behaving with the pointer. The pointer ptr based val is something we can give. Here I'm going to give I, and then marks of I, and then I'm going to give star ptr, and then once the star ptr is get, I'm going to increment that ptr basically here. And before that, we will assign, we cannot access that any variable before any local variable before initialization. I'm going to initialize with the to point that memory location of the 0th element of an array. Then I'm going to do this gcc -o ptr1 and then ptr1.c. Something I missed to initialize the type, comma I. Yes, now we should get, yeah, star ptr1. I'm going to enter the students numbers 65 and 34 and 23 and then 44 and 45, 45 and 66 and 77 and 47 and 85 and the last one 90. Now we are getting that value over here. Now you can see that the data content accessed by this marks of 0 is 65 and also the pointer content also 65, and here marks of 1 is 34, here also the pointer 1. Something similar to this, I am having that the locations something here, and I'm going to point, I'm going to increment here and I'm going to increment here. I'm in marks, I'm getting this content, and then marks of 1 this one and marks of 2 this one. Here we are playing with the pointer here, and once I get that content, I'm going to increment so that it points to the next element. I am incrementing again and it points to the next location. It keeps on moving with the array. This shows that array is then sequentially stored inside the memory, and you can use that pointer and initialize with the first location and keep on incrementing, and you can get the continuous values of an array of next contiguous elements accordingly. That we have seen over here. And for example, we can have another kind of array and multi-dimensional array that we can able to see here. For example, I'm going to use an multi-dimensional array. Maybe I can copy so that it will be easier. cp ptr1.c to ptr2.c, vim ptr2.c, so that I got that thing. Instead of marks, I can give that 2-dimensional. It should be leisure should be good, so that we can able to see marks 4 of 2. Then we can able to scan that here. I'm going to put comma j, and I'm going to enter, for example, marks of 0 means marks of physics of all the 4 students, and marks of 1 means marks of max that we can able to see over here. And I'm going to this one, it should be up to 4, and then we should have something similar to this, yy, and then p. I'm going to access that. Here we can do the similar way, j equal to 0 and up to j less than 2. Then we can get that marks of j and I. That means 0, 1, j will go, and I can go from 0 to 3. It's something like it should be 8 elements that will be given, and we can mix that pointer to both zeros location, and we can copy that here to yy, paste, sorry, to yy, and then we can paste it here, and then to dd. I can do that with printf, then pointer, marks of %d. I have to give j comma I. A similar way we have to give j comma I. We can check what is the value here. We are getting, we have to do in some way, and it should be consecutive, and we are more pointing to that. For example, two-dimensional, it was first 4 location and then next 4 location. That like that it will be assigned for a marks that we will see over here, how it behaves with the pointer. gcc -o ptr2 ptr2.c. I got compiled. I'm going to give input maybe 23 and 23, 45 and 67. The next array element, next dimensional element we are giving, and 75 and 86 and then 97 and then 100. We can give someone to 100, yeah. And we are getting enter the marks 34, 45, 43, 32. Sorry, something is wrong. I am missed. Something is wrong. Yes, I missed this one. Yeah, I missed not incrementing j. Similar, this one is to be. Yeah, sorry. Maybe you might have wasted 2-3 minutes with seeing some junk implementation. Now we will see. It should be good. 43 and 54 and 65, and I'm going to get 33 and 44, 55 and 66. Now we got that prints over here, and something like 24, 23, 43, 54, 65, 33 and 44, 55 and 66. How it should be? Something like this. It should be, we can define how it has to be. For example, I can define it here. Maybe I'm taking some time. Yeah, we have that insert. I can do that shapes. I can define here. This is that memory location for 4 bytes, 4 integers. If you consider it's a 4 integer, for example, this one is 1 integer. In the single dimensional, here it's something like we are pointing that our pointer here to this, and this is that completely. This one will be marks of 0, and then this is marks of 1, sorry, 1, and then we have 2 here, and then we have 3 here. That should be fine. And here we are making that pointer something like this, that I should enter the text box. Yeah, PTR I am getting here, initialized with marks of 0th address location. When we get that, when we print that content, we are getting marks of 0, and we are incrementing at that time. The pointer will come here, and then we are getting marks of 1, and then when we are incrementing again, that pointer will come to marks of 2 address location, and we are getting that marks of 2 value. Similar way, we can define an 2-dimensional array that will be something like this. it will be something like this, something in the sense a 0 up to this one, 0 1, we can define something like 0 and 1, and similar way we have 0 and we have the second element. Similar way we have 0 and then third element here. Similar, when we do that multi-dimensional, it should be something like this. It has been the memory availability will be like this. Maybe I can little scroll up. Yeah, and we are making this pointer to that location. Initialization with the two-dimensional array, we are pointing to this location, and then we are continuously incrementing the pointer. That's why we are getting that value correctly with the single and two-dimensional array pointing. Yeah, I can define pointing pointer to array manipulation. Yeah, this is good. Whenever we are incrementing, this will come here and coming here and coming here, and on the next increment it goes to the next element, marks of 1, and second marks of 1 of 1 and marks of 1 of 2, and then it moves to marks of 1 of 3, and it ends basically that our array traversing. It's something like we can do that, how we can make the pointer to array manipulate, how we can traverse into the array using a pointer, that we have seen over here. And we can also make something with the pointer, something like this, maybe a character pointer. For example, we have an array something like this, pointer 3.c. I missed include stdio.h and then integer main integer argc comma character star argv of 1, and then we will get something like this, return 0. Now we will be getting something like character, how we can play with the character. I am going to do with the characters something like this. I am character name equal to 64, and I am going to do with that for example, we can do this constant character name equal to Hariharan, and I'm going to print this, printf %s and then /n comma name. Yeah, gcc -move ptr3 and ptr3.c. we got compile ptr3, we got print that Hariharan. It's something like we does not allocated anything for that pointer, something which one is something here, it's pointing to that location. It's something like this, the cancer character star, it's pointing to that this memory location of this content basically, and we are printing here. Maybe we can do that some similar printing, how it behaves, and I'm going to do that yyp with the name plus plus yypp, so that we will get something good. We'll see ./ptr3. yeah, here we are getting something like whenever we are incrementing pointer, the pointer moves to the next character. Since it's a character pointer, it's moving to the next character. Here Hariharan, and it becomes Hariharan, and then Riharan, and then it becomes Iharan, and it becomes Haran, and it becomes Aran, it becomes Ran. It's something like we can play with that, the characters, the pointer with an array that we can able to play basically. And array is something like a memory location that it's statically allocated. Maybe we can move forward with the how we can allocate the memory in dynamically, that we shall move forward and we shall analyze in the next sessions. And thank you for watching. You can contact me at nvhariharan@nivitech.com. Thank you. Subscribe for updates. Have a nice day.